Hello everyone, welcome to the channel. Generating images from text prompt is fun, but there are a lot of things which go behind the scene, and I believe it is extremely important to understand few of the basic concepts which I often asked about whenever I do a video around stable diffusion models or whenever I cover some text to image generation model. In this video, I'm going to answer a very core concept about noising and denoising of the images whenever we are creating images from the text prompts by using AI models. I will try to keep it as simple as possible while ensuring that once you have watched the video, you are crystal clear about these concepts. The tool which I'm going to use for it is called as Comfy UI. I already have covered Comfy UI on the channel where I have shown you how to install it, and that is again a very easy to follow video which you can search on my channel and you will find it at the very top. So please do watch it out if you're looking to install Comfy UI. But that is not the topic of this video. For this video, as you can see, I'm showing you the Comfy UI interface. Now, whenever we are generating images from text prompt with the help of AI model, the usual process is that first a latent image is created. A latent image is simply an abstract, hidden, compressed image which is either based on an input image or an empty image. For example, if you see at this screen, we are simply using this empty latent image here. Again, if you want to know more about what exactly this latent space, latent image is, I have done a very easy to follow video which I'm more than sure you will enjoy. But for now, just remember that whenever we are creating an image from a text prompt, first a latent image is created. Latent means an abstract image. Secondly, a random noise is added to this image. Then the AI model denoises this image guided by the text prompts. So for example, in this window at the moment, you see, if you start from the left hand side, we have this model which is Dream Shaper, and then here we have two prompts. The top one is a positive prompt, the bottom one is the negative prompt. So in the positive prompt, we want this image to be created. The text prompt is beautiful scenery, nature, glass bottle landscape, purple galaxy bottle. And then what we don't want is text and watermark. And we are also providing a latent image here, which is an abstract or empty image. Now, on the basis of these two prompts and this latent image, our AI model is going to generate a new image. So how that works? The way it works is that first a random noise is added to this latent image. Then the AI model denoises this latent image guided by these two text prompts, and then a new latent image emerges here by K-sampler, which is then decoded back to the pixel space so that we can see it. This is how this whole process works. Now, you might be wondering what is this noise, why it is added, and then why we denoise it again to get a new image. Why don't we just change this image, the latent image in place and create a new one? Why do we have to add a noise and then remove the noise? So in this video, this is what I'm going to explain to you, why exactly this noise is added and why do we denoise it. So the in this video, I'm going to not only explain this process, I'm also going to show you a hands-on thing. So the node which is specifically responsible for this image generation process is called as K-sampler, which you can see here. This is the one. Let me first describe this flow and then I will explain the K-sampler and this noise and denoise. Let's start from the left. So again, this is the model we are using, Dream Shaper. Then this model is output model is connected to this K-sampler model, and then this positive and negative prompts are connected to these positive and negative prompts, and this empty latent image is connected to this K-sampler. So this is how it is working. So K-sampler takes these inputs the model dream shaper, positive negative prompt, and latent image. And then on the basis of these parameters, it creates a new image. So what it does is it first adds the noise, K-sampler adds the noise to a latent image. Noise simply means random unpredictable data, and adding noise to the latent image is just like introducing random errors or distortions to the blueprint. And let me give you an example. For example, the original empty image is some blue color sky with white clouds. And then when we add the noise, it means that along with that blue sky with white clouds, we have also added some random splotches of gray and black just to distort it. So now the noisy latent image is like corrupted version of the original. And then we do the denoising, or K-sampler does the denoising. Denoising is the process of removing the added noise from the latent image using the AI model and these two prompts, positive and negative. The AI model tries to restore the original image based on its understanding of what the image should look like. Now, example of denoise could be that our noisy latent image was blue sky with white clouds, but with random splotches of gray and black. Denoised image will be blue sky with white clouds restored to its original state. So we have restored it back. Now here is the interesting part. During denoising, the AI model doesn't just simply restore the original image. Instead, it uses the positive and negative prompts to create new details, textures, and patterns that were not present in the original image. So the resultant denoised image could be blue sky with white fluffy clouds and a few birds flying in the distance. The new denoised image is combines the element of the original with the AI model's own creativity. So that is why we do the denoising and noising. And this process allows the K-sampler node to generate new unique images based on the original latent image and the in these prompts provided. So again, you may ask why noise and denoise. So there are few reasons for it. First, denoising allows the AI model to explore new possibilities while still being guided by the original image. By introducing noise and then removing it, the model can discover new combinations of features, textures, and patterns. And the way noise is added is through this seed. So if you click here, you can change the seed to maybe 0, then there will be no noise. And once you run it, there will be just clicking on Q prompt, you will see that it is running and nothing has been added to it. So let me see 0 here and click on OK and then Q prompt. You see, once I remove it, it just randomly put something here. Maybe I'll just say something like this, click OK and then Q prompt. It has again changed it. So it is just depending upon K-sampler stuff. So this is how it just adds some random numbers. That's it, and creates a new unique thing. Every time you will do it, every time there will be a new image. There are ways of keeping it static, but that is for another video. So for now, you just need to remember that this seed is primarily adding the noise to the image, and this denoising is helping not only preserving the overall structure and composition of the original image if there is any, or the text prompt, but also it adds model's own creativity. Another cool thing is that it helps in avoiding overwriting. So for example, if your text prompt says bottle, it is going to use the bottle, not anything else. But by the way, you can also input images. So for example, if your image is of white or blue sky with white clouds, it is going to retain that with the help of this noising and denoising. And then denoising also enables the emergence of unexpected features and patterns. By introducing randomness, which is noise, and then resolving it, the model can create new combinations that is not simply possible through direct manipulation. And then from technical perspective, denoising is way more computationally efficient and stable than directly generating new images. And it also, by the way, helps us in the issues like overfitting. Overfitting means that when an AI model becomes too specialized to the training data, that is where it memorizes its training data instead of learning general patterns. For example, a model which is overfitted on cat photos of your own cat will recognize your cat's photos, but it will fail to recognize other cats. So that is what overfitting is. So that's it. I hope that you enjoyed it and now you understand what exactly is meant by noising and denoising. Why do we do the denoising and how case sampler plays a role there in order to use the seed to noise, and then it also denoises on the basis of the positive, negative, and then the latent image. So, but if you still are confused about noising, denoising, case sampler, and all that, please put your comments in the video below the video, and I will try to answer it. Also, before I let you go, let me give a huge thanks to AgentQL. AgentQL is the sponsor of this video. AgentQL is a query language for extracting data from web pages quickly, easily, and at scale. You can use the Python SDK to run your queries in production using Playwright, and use the browser-based debugger for optimizing queries in real time on any web page. So that's it, guys. If you like the content, please consider subscribing to the channel. If you are already subscribed, please share it among your network as it helps a lot. Thank you for watching.